Hey again, it's Mr. Lum, and today we're going to be talking about naming compounds, and in particular, we're going to be doing naming ionic compounds. But before we do that, first what we need to look at is identifying what is an ionic compound. So there's two types of compounds that we're going to be discussing in this course. The first is going to be ionic compounds, and the second is going to be covalent compounds. So there's a couple of differences between ionic and covalent. We've discussed this before, but we'll go over it again. The easiest way to identify if something is ionic is that it has a metal and a non-metal. If something is covalent, it has two non-metals. Or in other words, ionic has a positive ion and a negative ion. And again, covalent are two non-metals. Where are the nonmetals on the periodic table? There is this kind of black, what we call the staircase, because it looks like a staircase, and right here, and this is the division between nonmetals and metals. So on this side of this staircase, in these two different colors right here, in these kind of colors right here, are the two different non-metal groups. And then everything else are metals. So I have a couple of compounds listed in this row right here, and what we're going to do is we're going to identify if they are ionic or covalent. So the first one is C and O. Now a lot of people want to say that C and O look like this one right here, cobalt. But it is capital C, capital O. Cobalt is capital C and then lowercase o. So this is not cobalt. So capital C is right here. It is carbon, and capital O is right here, which is oxygen. Since they are both non-metals, this right here is covalent. Now for the next one, which is CO2, same thing. It doesn't matter that it has that 2 right there. We'll talk about those numbers later. But again, carbon, oxygen, therefore this is also covalent. We have NaCl is our next one. Na is right here. Cl is way over here. And so again, this is metal, and this one is a non-metal. So this is ionic. Okay. Next one, we have a really kind of a tricky one. We have HCl. H is here and it's over here. But I want us to remember that H, or hydrogen, is going to be a non-metal. Okay, so since hydrogen is a non-metal, Cl is also a non-metal. We just talked about it right over here again. So since it's non-metal, it's going to be covalent. Now, aluminum and oxygen, which is this one right here, aluminum is right here. Oxygen is, we already circled it before, so aluminum and oxygen. Aluminum is just barely on the metal side, but it's still a metal, and so therefore this is ionic. MgO, magnesium is a metal, oxygen still that non-metal, so metal and non-metal is ionic. LiF, Li is way over here, F is right there, and so therefore this is metal and non-metal, this one is ionic. So it's important that we are able to identify if something is ionic or if it is covalent, because that is going to determine how we start naming these compounds. So let's take a look at naming some easier compounds first. So again, this is just a recap. We've done this already. Ionics are positive and negative ions form a bond, compared to covalents, which are nonmetals. These ones are metals and nonmetals. Now another big difference is that ionic compounds give and take electrons. So electrons of ion is given to another ion. So some of them give away electrons and some of them take electrons. Compared to covalence, they share electrons. So those are some other bigger differences. But when it comes to naming, we don't need to really know that. We just mainly need to know this metal and non-metal stuff. And again, we can see that metal and non-metal stuff over here. Okay, so we're going to learn about basic naming of ionic compounds. So I have 3 steps right here. Name the positive ion, then name the negative ion, and then add the suffix "ide" to the negative ion. The suffix means the ending of a word. End of word. So right here we have Mg3N2. I look up Mg on my periodic table and I've taken a slice of the periodic table right here. So here's Mg right here. And so I name the positive ion first. Mg is the positive ion, so I'm just going to write it down and write magnesium. And then I'm going to take the negative ion next, and I look it up, and N is nitrogen, so I'm going to write nitrogen. So I've done steps 1 and 2 for this one right here. Now step 3 says add the suffix or the ending of a word and change it to "ide" for the negative ion. So here's the ending of the word right there. And what I'm going to do is I'm going to change that to "ide." So I erase the old ending and I change that to "ide." So it now becomes magnesium nitride. I do the same thing for the next one. Name the positive ion first, sodium. Name the negative ion second. And we look it up and it's chlorine. I take the old suffix, "ine," get rid of it, and write "ide." There, so it becomes sodium chloride. You can put the video on pause and try doing these other 2 right here. And I'm going to come up with the answers. Now, so the next ones are magnesium fluoride and aluminum oxide. Okay, so once you get a little more practice, you can stop erasing the old chlorine and changing it to chloride. You can just start to kind of realize, say, hey, it's supposed to be sodium chloride or fluoride or oxide. Okay. Now, when you are naming these basic ones right here, you can somewhat ignore these numbers going in this direction, and I'll talk about why those numbers are important in the next slide. So here we have how to go the other way. So writing the ionic compounds and when we're given a formula. So right here we have magnesium phosphide. And so the first thing I'm going to do is I'm going to write the positive ion first. And I don't have a section of the periodic table, but if you looked at the periodic table for magnesium, it looks like this. Mg2+. Okay? And if we're to look up, the next step says write the negative ion second. And if we look up phosphorus or phosphide, it says P3-. Okay? Now, I'm going to show you 2 ways to do it for this third step of saying make sure that the total charge is 0. That's one way of doing it. The other way of doing it, or, I'm just going to write or, you can use the swap and drop. So we're going to do the make sure the total charge is 0 method. So right here, 2 plus 3 minus, that would equal -1. So we need more positives. Now it's had a total charge of 4 plus and 3 minuses. So the charge is not 0. So I'm going to add another 3 minus. Okay. Now the charge, I know it seems long, but now the charge is -6. The positive charge is +4, so I'm going to add this, Mg2+, And what we have now is that this total charge is now plus 6. This total charge is now minus 6. Okay, so the charge now is 0. How many mg's did we use? Well, we used 3 mg's. How many phosphoruses did we use? Well, we used 2. And that is the formula for magnesium phosphide, Mg3P2. That is this whole making sure the total charge is 0. Okay? The swap and drop method just says this. Mg2 plus P3 minus. I write it down below. Mg and then P. And I take this, just the 3, and I swap and I drop it down there. The same thing with the 2, I swap and I drop it down there. And then what it becomes is that 3 goes down here and the 2 goes right here. So you get the exact same answer, right? One way, technically this way right here is the scientific way. This is the quick way of doing it. Okay? So both ways are fine. And I'll probably go and use these two ways interchangeably in the future. So anyways, aluminum bromide, I looked up aluminum right now. It's aluminum is 3 plus, bromine is 1 minus. If it just has a minus sign there, technically there's a 1 in front of it. I'm going to use the swap and drop method. And then we're going to write down a 1 and a 3. Okay? Now, we don't write the number 1. Don't write 1s, so it just becomes AlBr3. Okay? We never write number 1s in this kind of thing. So if you can think of it as like a very famous compound that we know, like H2O or water, we don't write H2O1, we just write H2O. Okay, so we don't bother writing the 1s. Okay, so it just becomes AlBr3. Oh, here's the periodic table right there. Kind of forgot about it. Okay, a couple of practice ones we're going to go through fairly quickly. This one I really wanted to do, this magnesium oxide one. So I know it's very, very small, but hopefully you have a periodic table in front of you. But here's magnesium right here, and it says Mg2 plus, and here's oxygen way over there, O2 minus. Now, if you want to swap and drop, it would become like this. It would look Mg2O2. Okay? What you'd have to do to that is realize, hey, I have a common denominator, and so this would become just MgO. Now, if you were to do that zeroing method, you should realize that 2 plus, 2 minus, it already has a total charge of 0, and so we just use 1 Mg and one of the O's, so it's just MgO, and so that's the right answer. Do not write Mg2O2. This is wrong. Okay, so it should be MgO. Okay, so I'm going to do aluminum oxide right now. So Al is right here. It's 3 plus. Oxygen is 2 minus. Just going to give myself a little divider right here. Use the swap and drop method because it's faster. 2 comes down here, 3 goes over there. So it's Al2O3. And that's our answer, just like that. Okay, now we have going the other way. And this, when you go from this way, when you have the formula and you need to make the name of it, you don't need to, you can pretty much just ignore all those numbers for these simple ones. So anyways, we have this one right here, which is Li, okay, and I look up the name of it, and it says it's lithium. So I'm going to write that right here, lithium. We have O again, which is oxygen. But we're going to change that to oxide because of the suffix. So I'm going to change it to oxide. And so that's our name, is lithium oxide. I do that again for this next one right here, Al2S3. Al is aluminum. And S is sulfur. We're going to change that to sulfide. Okay.